generate result rapidly, and the last, even untrained personnel can interpret the end result. Okay, so the first thing before I develop lung cancer, I need to develop an electronic nose. I need to know what am I going to detect. So I analyzed 17 breath analysis results from all the journals and found out that the best markers is alkane. Why? Because its concentration in those exhale breath from the lung cancer patients is twice of the concentration from the normal patients. In other words, the alkane concentration in healthy people is much lower. And its concentration is elevated because of the oxidative stress. This means that other lung diseases like asthma and tuberculosis, where the pathogenesis does not have any relationship with oxidative stress, will not increase the concentration for alkane in their breath. And the second thing I'm going to do is to find out what are suitable sensor materials to develop the electronic nose. The first material is tetracosan, because it can dissolve alkane, and it has been used for many studies when they want to detect alkane concentration. And the filler is carbon powder, because it can conduct electricity and it is low cost. With these materials, I am able to develop a chemi-resistive electronic nose, because it can detect alkane from using the matrix, the tetracosan, and it can also display resistance change when it detects the alkane. So I want to deposit the sensor materials onto the substrate in order to produce an electronic nose. And all these methods I tried is not suitable. They fail sometimes to create an electronic nose. So I developed my method of, this is a layer depositing method, and it reached a 100% success rate in developing operative electronic nose. So what I do is to place a tetracosan onto a substrate and heat the substrate in oven for 30 seconds at a temperature of 110 degrees Celsius. And later, I put the carbon powder on it and then heat it again. It's very simple, but it can reach a 100% success rate in producing an electronic nose consistently. Okay, so this is the final design of my sensor. As you can see, the substrate is just a simple circuit board, and the sensor materials is deposited in between the interdigited carbon strips, and the wires are connected to the carbon strips. And since my chemi-resistive sensor this is how it works. When there is alkane analyzed in the air, it will detect the alkane and its resistance will change. So I use a digital multimeter to measure the resistance of sensor. Once there are alkane in the air, the resistance of the sensor will change, and it can be detected from the multimeter. And this is the sensor output. The sensor output is use the resistance change and divided by the baseline resistance. This is the whole apparatus when one wants to detect whether have lung cancer or not. So this is a digital multimeter where the electrodes are connected to the sensor in the detergent bottle. So if you want to exhale, you exhale through the straw into the detergent bottle, and in the detergent bottle there are sensors at the bottom of it. Alright. Then the next one is the